Hi students, let's look at this question here, which is on binomial expansion. Let's see how we can do this proficiently. So in the expansion of 1 minus 2b to the power of n in the ascending power of b, the coefficient of the third term is 1, 1, 2. Find the value of n. Okay, great. So I think this is pretty okay. What we need to understand is that if we're looking at the third term, I think I will not use the general formula. Later I will explain. So how do we understand binomial expansion properly is that you just understand that whichever we do, okay, you need a third term, right? You start counting from 0. So essentially what happens here is you always have pairs like that, okay? And because I do not know where it ends, the n is unknown, what I'll do is I'll just put this as n, and 1 minus 2b, and 1 minus 2b, and n 1 minus 2b here, okay? So here what we'll get is essentially counting. There's a pattern recognition here, which is always start counting from 0, 1, 0, 1, 2. Then because you're ascending the power of b, there will be 0, 1, 2 as well. Okay. Now obviously then this will be descending n minus 1 and n minus 2, but because it doesn't really matter, right? The third term here. So this is the third term. So third term will correspond to 2 because we start counting from 0. Okay, so this is the reason why we use tr plus 1. Sometimes it can be confusing, but the idea that is tr plus 1, then you raise it to the power of r because we start counting from 0. So this case here, what we get is essentially the third term is n choose 2. 1 about n minus 2 is just 1, and this will be minus 2 square b square. So the coefficient will be this. Right, this is the coefficient. So the coefficient of the third term is 4 n choose 2, which is this guy here. Without this is the coefficient. This is the coefficient here. All right, then what we're going to do next is we're just going to write in the coefficient given in the question, which is 1, 1, 2. This is 4. N choose 2 will be, we could just manipulate it, is n minus 1 over 2 factorial. Okay, so I'm not going to explain why n choose 2 is this expression, this expression here. Yes, so what I'm going to do is just manipulate this over here. This will be 2. So 112 divided by, that would be 112 divided by 2 equals to n minus 1. So 112 divided by 2 to be 56. It's n squared minus n. So 56 minus 56. Okay, 56 would be 56 divided by 8 times 6. So that will be 8n plus 7. Okay, this is it. So hence n is equals to 8 or negative 7. Now n could be negative 7, okay, but this question didn't imply, right? So I think what you say is in the expansion of this, where can we just put a where n is a positive integer? Okay, so I think the question is asking for positive, because in fact you could use negative 7, right? So reject as n is bigger than 0. So hence n is equals to 8. Okay, so this question is not phrased properly. You need to indicate that n is a positive integer. So without writing the expansion of 1 minus 2b, explain why the coefficient r plus 1 term is n. Okay, come, let's look at that. All right, so if we were to expand, if we were to expand the nth term, so r plus 1 term, sorry, so the general term r plus 1 term is tr plus 1. This will give us n choose 2, n choose r, sorry. Look at the expression there. N choose r, and that will be 1, okay, 1 minus 2b. This will be r, this is n minus r. Okay, so this could be simplified. This n will be 8, right? R. Then this will be minus 2r, and this is b r. Now, so what we need now is actually, okay, now we need, you look at this 2 here, we just factorize this 2 up. So this case there will be 8r, this is minus 1r, 2r, dr. We need to explain why this is an even number, okay? This is our key. We don't really care what number holds behind, but what we know is that any number multiplied by 2 will be an even number. So you see, write down, since 2r is an even number, okay, and and the multiplication between an even number with another number is always even. Okay, so essentially, you give me an even number. If you take an even number multiplied by 2, even number multiplied by any number, even multiplied by even will be even. Then even multiplied by an odd number, it will still be an even number, right? So hence, tr plus 1 is hence tr plus 1 is even. Okay, so that's what you do. So you just need to show that 2r tr plus 1 can be separated into an even number multiplied by another number. That's all, right? So that's how you do this question proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.